So in this video we're going to integrate sine of 2x divided by 1 plus 2 cosine squared of x with regards to x, and then our parameters of integration are from 0 to pi over 2. Now at the end of this video I'll draw a graph of this and display that at the end of the video after we've done all the calculations for this integral. Okay, so first problem here we've got is sine of 2x and cosine squared of x. So our inputs are different. We've got x and 2x. So we need to find a trig identity for either this one or this one, so the inputs are both the same. Now there is one for cosine squared of x, and that is cosine squared of x. That is 1/2 of cosine of 2x plus 1. So that's the trig identity that we can use for cosine squared of x. So therefore our 2 cosine squared of x, so 2 cosine squared of x, that's just going to leave us with cosine of 2x and then add 1. So that basically effectively cancels out the half. So that's pretty handy. So our whole denominator will then become cosine of 2x plus 2. So let's rewrite the integral with that in mind. So from 0 to pi over 2, sine of 2x over cosine 2x plus 2. So cosine 2x plus 1, which is what this is, and then add this one here. Okay, so now we're ready to do a u substitution as we've got the same input for our trig functions. Now I'm going to choose cosine 2x plus 2. That way then when I take the derivative, I'll get rid of my 2 and I'll be left with something to do with sine of 2x. So let's do that. So u equals cosine 2x plus 2. So usual business when trying to do u substitution, take the derivative. Derivative of cosine 2x, well the derivative of cosine is negative sine. The input will stay the same, and then by the chain rule we take the derivative of 2x, which is just 2. So we've got minus 2 sine 2x, and the plus 2 will disappear. So then that will be dx. So now to get dx on its own, so dx equals du over minus 2 sine 2x. Okay, so now let's transfer this into u. So let's go with that. So I'll come to the parameters in one moment. So sine of 2x, I'm just going to leave that in there at the moment because we'll see that will disappear. Our cosine 2x plus 2, that's just u, so we'll leave that in there. And then our du, and to do the dx, will become du over minus 2 sine 2x. So we've got du. Now the minus, I can put in here, minus 2 sine 2x. So I'll just leave it like that. So now sine 2x's both cancel out, because as we're in our u variable now, we don't want the x inside here because it's meaningless. So now we've got minus 1/2 with our du. So now this just cancels out now into 1 over u du times minus 1/2. But we need to take care now of our parameters of integration. So let's have a look at when x equals 0 and find what our u becomes for that. So for x equals 0, u equals cosine 2 times 0, which is just 0, and then add 2. Well, cosine of 0, this is just 1, so therefore u will equal 3. Basically got 1 plus 2. So here for our lower bound on our integral, we got u equals 3. Now what about when x is pi over 2? So if x equals pi over 2, u equals cosine 2 times pi over 2, which is just pi, and then add 2. Now cosine of pi we know is minus 1. Minus 1 plus 2, that just gives me 1. So for our upper bound, we've got u equals 1. Okay, let's rewrite our integral. So now we've got minus 1/2 and 1 over u. That's a nice integral to be doing. And then du. Okay, now our parameters of integration, now with the u, we've got 1 and 3. So interestingly, we've got our upper bound is lower than our lower bound. So our minus signs here, what we could do is we could take away that minus sign and flip the parameters. So that would then become a plus, and then on 1 and 3 we could just switch round. Okay, now it's just simply calculate this integral, which is natural log of u. So we've got 1/2 times ln of u from 1 to 3. Okay, well, let's plug in when u is 3. So this then equals 1/2 of natural log of 3. And then what about when u is 1? Well, natural log of 1 is 0, half of 0 is still 0. So we've got half of natural log of 3. Now this just simplifies down to log of 3 divided by 2. So let's just write that as our answer. So we've got ln of 3 over 2. So that's a nice simple result. It's quite a few bits of trig identity to get to our answer. Okay, so now on this video I'm going to show you a graphed by the Desmos graphing calculator of this integrand to show you our integral. Okay.